So your MCS2, spring 2019. Okay, good. Paying attention. We want to discuss the factorial example in our recursive programming. Okay. So LISP, we want to define a recursive factorial. Then the define command and the name of function can be factor or represent the recursive version of the factorial. And factorial function will take one argument, one number. That will be one number. So we can write in the argument list, we should write one symbol that will represent that number which will be passed to this function as argument. So in this case now, x is not list. Okay, this example is different from previous example. In previous example, we are passing list to x and we are applying the check of null function. Okay, now recursive program will have the conditional statement, and in the default class we should not be applying that null function because x is not a list, x is a number. And the base case of the factorial recursive process is that when the number is 0. So we should be calling equal function when x is equal to 0. By definition 0 factorial is equal to 1. Therefore, we should return 1. This is the base case. This is the stopping condition. When it is not equal to 0, we are defining the factorial for all positive integers, positive numbers. Okay, not the negative ones. Okay. When it is not 0, it means it is greater than 0. When it is greater than 0, factorial in the default class, we write that factorial is basically multiply, factorial of any number is basically multiply that number with the recursive call, multiply x with the recursive call of factorial on the reduced decremented value minus x1. 1 should be on the right side. Okay? 1 will be subtracted from x and factorial or will be called, this is the recursive call within that multiplication function. Over here the multiply will close, t close, con close, and our function definition close. Okay? Now, in order to fully understand it, we should be tracing it with some sample value. Okay? We want to call the factorial function, the factorial recursive function on 4. 4, before applying the function, 4 will be evaluated to itself. And the actual argument 4 will be passed to the variable x. After matching the underline with the function call, go to the definition, there are two clauses. Equal x 0, 4 is equal to 0? No. The exact class condition is false. Go to the default class. In the default class, whatever the multiply will return, that will be the return value of factor r. Okay? We want to see how the multiplication operator is operating on what arguments before applying the multiplication operator. First argument, supplied argument is a symbol x. Symbol will be evaluated to its value. What is the value of x? 4. And the recursive call, this is the function that we want to trace. Therefore, we have written the name of the function on the 4 minus 1, 3. On 3, on the reduced number, decremented number. So, now multiplication is waiting for the result of this recursive call. Multiplication is waiting for the result of this recursive call. And in this recursive call, the actual argument is 3. The value of x for this function will be 3. And it will check the default class equal to 3, 0. No, 3 is not equal to 0 obviously. It will go to the default class, multiply 3 with fact r, and 3 minus 1, 2 will be passed to it. Now in the definition, value of x is 2. The exact class, the first class will be checked. Is it equal to 0? No. Obviously not. Control go to the default class again. That multiply 2 with factor 1. In this function call, nested recursive function call, value of x is 1. Exact class, the first class condition will still is still false. 1 is not equal to 0. So multiply 1 with factor 1 minus 1, 0. 1 minus 1, 0. The factor recursive call will be made on 0. So, in this case, value of x is 0. This 0 is equal to the 0 written in the code? Yes. The condition is true. The Z class condition is true, then part will be executed, that one will be returned by that function which is getting 0 as argument. So now multiply has got its second actual argument 1. 1 into 1, 1. 1 into 2, 2. 2 into 3, 6. 6 into 4, 24. I hope it was understandable.
Yes.
Okay, quickly note it down. We shall move to the next thing.